Hello everyone, welcome to the course Formal Languages and Automata Theory. Let me give a brief introduction about myself and Tulasi Chitra, Associate Professor in Department of Computer Science and Engineering, MLR Institute of Technology. Let me give you a brief introduction about Formal Languages and Automata Theory. Just share me a screen to discuss about the introduction part. These are the topics today we are going to discuss. What is formal language and automata theory? Why to study formal language and automata theory? What is the primary goal of automata theory? What are the prerequisites, books and references, syllabus, course outcomes? First, what we are going to see is what is formal language and automata theory. In this, we are going to discuss about these three concepts. What is language, what is formal language, and what is automata theory. What is language? In general, we know that language is used to communicate with each other. Suppose you consider if two human beings are there, how they are going to be communicated with each other. How they are going to communicate with each other. This represents a language. Normally, we are going to have English, Telugu, Tamil, and different types of languages out there, right? And coming to formal language, what is formal language? A language which is used to communicate between human and a machine. We're going to have human and machine. Machine is nothing but a computer here. How these two are going to be communicated with each other. And the formal languages are more accurate when compared to the normal language. Why means you don't find any ambiguity over here. And coming to automata theory, here it is used to build the mathematical models of a machine, right? We are going to have models to be developed over here. Coming to why to study these formal languages and automata theory. This is one of the core subjects in computer science and information technology. And this formal languages and automata theory is also known as theory of computation or automata theory. And here, mainly we are going to concentrate on computation of machines in a theoretical way. Up to now, what are the programming languages, what are the Android we have seen, that comes under the practical things. And here, the subject is going to give you a clear idea about how computations are going to be done in a theoretical way. The course division has been done based on the three theories. One is computability theory, other one is complexity theory, the other one is automata theory. And what is the primary goal of automata theory is to build the mathematical models for a machine. To show the example between how this complexity, computability and automata theory are interrelated with each other, I will be taking one simple example and showing you how all these three theories are interrelated with each other. Here we are going to consider a machine and a task to be solved by this machine. Now, based on this machine and the task, we are going to discuss about this computability, complexity and automata theory. Suppose a task is given to a machine to be solved or not solved. That tells you about the computability theory. If the task is solved by the machine, by that we will be knowing how much time and space is required to solve the problem and what are the steps that are required to solve that problem. That gives you the complexity theory. And making a mathematical model for a machine from that complexity theory is nothing but automata theory. And in automata theory, we are going to discuss about DFA, then NFAs, and then we are going to discuss about push down automata, and then Turing machines. All these concepts we are going to discuss in this automata here. And by using this mathematical model, directly we won't be getting the designs. For that, we require some software and hardware to be placed in a machine to have a design to be developed. I will be showing that one by a pictorial representation, how we are going to model a new machine. We are going to have the mathematical model for a machine to be developed from the automata theory, right? And from this model, we are going to write the programs. That means by using some programming language, we are going to write the programs and that becomes the software. And with directly software, we are unable to design a model, new model or new design for a model. That's why we are going to place the software in a hardware. Now placing hardware and software, we are going to develop a new machine. We are going to design. Now this is one of the simple examples to show how we are going to have a model to be developed. Here the electrical switch consists of two states. We all know this. One is on and another one is off. Pushing the switch converts from one state to the another state. And we know that off and on are the states for an electrical switch. The same thing we can be represented by using a model, right? How this works. When you are going to push the machine off state, then it will be in the on state. When I am going to push the machine on the on state, then it will be moving to off state. This can be represented mathematically by using the symbols like Q0 and another one is Q1. One is representing off, another one is representing on. Now, by pushing them can be represented by using the arrows. This is called the transitions, right? In this way, we can represent, this is one of the model that can be designed for an electrical switch before it is developed, right? Next, coming to the prerequisites. We require discrete mathematics and data structures and algorithms for our formal languages and automata theory. Why means from the discrete mathematics, we are going to use sets, relations, some functions, and graph models or graph symbols to be used. And from algorithms, how a problem can be solved stepwise. These are the two prerequisites that is needed for our subject. Books and references. John E. Hopcroft, Raju Motwain, and Woolman, Introduction to Automata Theory, Languages and Computation. This is by Pearson Education, India. And another book, Theory of Computation, by K.L. Mishra and N. Chandrasekharan. This is another book you can refer for studying the subject. And coming to the syllabus, we have totally 5 units. The 5 units are one interrelated to each other. In this syllabus, you have totally 5 units. In unit 1, we are going to completely discuss about finite automata, that is DFA, NFA, NFA with epsilon, minimization of DFA, Moore machine and Miller machine. And in unit 2, you are going to discuss about regular expressions, converting regular expressions to finite automata and vice versa, regular grammar, converting regular grammar to finite automata and vice versa, pumping lemma and its properties. Next, in unit 3, we are going to discuss about context-free grammars, derivation trees, leftmost derivation and rightmost derivation, ambiguity, and minimization of context-free grammars by using Chomsky normal form and Gribbage normal form, and properties of context-free grammar. And in unit 4, we are going to discuss about push-down automata, context-free languages, acceptance by empty stack, final state, Turing machines, and designing of Turing machines. And with continuation with the 4th unit, we have recursive enumerable and recursive enumerable languages, universal Turing machines, context-sensitive grammar, and linear bounded automata and post correspondence problems. All the 5 units are interrelated with each other. That's why this has been given with an interrelation by Chomsky hierarchy. Course outcomes. By the end of the course, the student can able to use the basic concepts of formal languages of finite automata techniques to design finite automatas for different regular expressions and languages, and to construct context-free grammar for various languages. Then to solve various problems of applying normal form techniques like Chomsky normal form, Ribach normal form. Then we are going to use pushdown automata and Turing machines. Thank you one and all.